You poured the peroxide. The gnats are gone. You felt like you won. 3 weeks later, your plant is dying, and you don't know why. Leaves yellowing from the bottom up, new growth stunted. Roots that looked fine yesterday are turning brown today. You water more. You move it to better light. Nothing works. You did everything the viral video told you. 1 part peroxide, 4 parts water. It promised a miracle. It delivered a funeral. Here's the truth nobody is telling you. That peroxide didn't just kill the gnats, it sterilized your soil. Every beneficial fungus your plant's roots were connected to, gone. Every microbe that was feeding it nutrients, dead. You didn't save your plant. You cut its lifeline and called it pest control. And the worst part? Right now, somewhere, another gardener is watching that same viral video, mixing that same ratio, about to make the exact same mistake. Today, I'm going to make sure that's not you. 3 things that decide whether peroxide saves your garden or quietly destroys it. The real cost you're paying every time you pour, and 4 situations where peroxide is actually the smartest tool you can grab. By the end of this video, you'll never look at that brown bottle the same way again. Factor 1. Your soil type. Most people think soil is just dirt. Brown stuff that holds your plants up. Something you scoop and pour and water. It's not. Healthy soil is the most crowded ecosystem on this planet. A single tablespoon contains more living organisms than there are humans on Earth. Bacteria, fungi, microscopic worms, each one doing a specific job to keep your plant alive. And here's the part that changes everything you thought you knew about peroxide. Every single one of those organisms carries a built-in defense system. Scientists call it an enzyme shield. When peroxide touches them, they don't die quietly. They fight back. They release a compound that rips peroxide apart in seconds, turning it into harmless water and oxygen. Millions of microbes, all firing at once. That fizzing you see when you pour peroxide into soil? That's not peroxide killing pests. That's your soil killing the peroxide. Now here's where it gets practical. You can test your own soil in 30 seconds, right now, before you ever pour peroxide into it. Grab the bottle from your medicine cabinet. Pour 1 tablespoon onto the soil of any plant you own. Watch what happens. If it erupts. If it bubbles like a tiny volcano, foam climbing up out of the pot, your soil is alive. It's healthy. It's packed with the microbes your plant depends on. And in this soil, peroxide gets neutralized in minutes. It will not kill your pests. It will only stress your soil for nothing. If it barely fizzes, if you see a few small bubbles and then nothing, your soil is close to dead. This usually happens with old potting mix that's been sitting in the same pot for years, or commercial soil that was heat sterilized before it was bagged. In this soil, peroxide stays active for hours, long enough to kill fungus gnats, but also long enough to wipe out whatever microbes were still hanging on. This is the #1 reason your friend's peroxide trick worked and yours didn't, or yours worked and theirs didn't. People growing houseplants indoors usually report success. Their potting soil was already low on microbes. Peroxide had room to work. People growing vegetables outdoors, building soil over multiple seasons, usually report failure. Their soil is alive. Their soil fought back. But here's the twist most gardeners miss completely. The people who failed with peroxide outdoors, they didn't actually fail. Their soil protected them. The same soil that neutralized the peroxide also saved itself from being destroyed by it. They lost the battle against fungus gnats, but they kept the war they didn't even know they were fighting. The people who succeeded indoors, they traded the last microbes their soil had left for a few dead gnats. They won today. They might be losing the next 2 years. Factor 2. The pest you're dealing with. Here's something almost nobody talks about. Peroxide doesn't travel. Most insecticides you buy at the garden store work systemically. You spray them on leaves, the plant absorbs them, and the chemical spreads through the entire plant. Bugs that bite a leaf 2 weeks later still die. That's how modern pesticides are designed. Peroxide does none of that. Peroxide only kills what it physically touches, in the few minutes before it breaks down into water and oxygen. Pour it into the soil, it does not move up to the leaves. Spray the top of a leaf, it does not reach the underside. The roots don't absorb it. It doesn't evaporate and settle somewhere else. It hits, it acts, it disappears. Any pest that wasn't standing exactly where you poured, untouched. This single fact explains every confused experience you've ever had with peroxide. Let me map this out for you. Aphids on a new shoot. When you spray them directly, they die. Soft bodies, no armor, the spray lands on them. Peroxide wins. Fungus gnat larvae in the soil. When you drench it, they die. They're sitting in the soil. The peroxide reaches them directly. Adult fungus gnats flying around the pot. They live. They were in the air when you poured. The peroxide never touched them. Spider mites hiding on the underside of leaves. They live. You sprayed the top. The peroxide ran off before it ever reached them. Hard-shelled beetles on your plants. They live. Their armor is too thick. The rule is simple. Soft body, plus direct contact, plus the pest isn't flying away. Drop any one of those three conditions, and peroxide fails. If you want to see how serious that hard shell problem is, listen to this. In 2009, 2 German scientists were trying to study the internal anatomy of ants. To see the structures inside, they had to make the outer shell transparent. Their tool of choice? Hydrogen peroxide, but not the 3% bottle you buy at the drugstore. They needed peroxide at 35% concentration, 12 times stronger, and they had to soak the ants in it for up to 13 days straight. 13 days. Industrial strength peroxide. Just to get through the shell of a single ant in a lab. So when you take that same drugstore peroxide, dilute it down to 1 part in 5, and spray it on a beetle for 5 seconds. What chance do you think you have? 0. The beetle walks away, but that same diluted solution will still damage soft leaves and the microbes in your soil, because they don't have armor. You're not killing your pest, you're hurting everything else. Factor 3. How you're using it. Now we get to the part that does the most damage. Because this is where the viral videos got the math completely wrong. The formula every viral video repeats. 1 part, 3% peroxide, 4 parts water. Pour it into the soil. Sounds diluted, right? You took something weak. You watered it down. You made it safer. Let's actually do the math. 1 part of 3% peroxide mixed with 4 parts of water gives you a final solution of 0.6%. Less than 1%. Still sounds diluted. Still sounds safe. But here's the question nobody asks. Diluted compared to what? In 2014, researchers studying trifoliate orange seedlings did something the viral videos never bothered to do. They measured the exact point where peroxide starts damaging the fungal network in your soil. The network your plant's roots actually connect to, the one that delivers water and nutrients from inches away. The number they found was 0.00003%. Read that again. 0.003%. That's the threshold. Above that, peroxide starts ripping apart the network your plants depend on. Now let's put those two numbers next to each other. What you're pouring into your soil. 0.6%. What your soil can actually tolerate. 0.00003%. Divide one by the other. You're not using a dose that's a little too high. You're not using a dose that's twice as strong as it should be. You're using a dose almost 2,000 times higher than the threshold where damage begins. 2,000 times. This isn't me exaggerating. This isn't dramatic framing. This is 6th grade math. 0.6 divided by 0.00003. Punch it into any calculator on your phone. And here's what's worse. The viral videos didn't lie to you on purpose. They just don't know this threshold exists. They saw peroxide kill fungus gnats and called it a win. They had no idea that the same dose killing the gnats was also killing the underground system keeping the plant alive. They won a small battle. They handed you a war you didn't know you were fighting. Now let me show you what this same math does to leaves. Remember the gardener I mentioned at the start? Her name on Reddit was Top Shot Tiger. Here's what she actually wrote, word for word. Do not directly spray 3% hydrogen peroxide onto leaves for powdery mildew. I did this for my pumpkin and cucumbers, and the leaves are now covered in brown splotches. Warning for anyone else who tries this. Why did this happen to her? The maximum safe concentration for spraying leaves is 1%. She used 3% straight from the bottle, 3 times higher than the burn threshold. Her leaf cells didn't just get stressed. They got chemically burned. The brown splotches were necrotic tissue, dead cells. She didn't do anything wrong. She did exactly what the viral video told her. The video just forgot to mention the ceiling. And nobody tells you, until your plants are already dying. Part 3. The real cost. Let's say you got lucky. You poured the peroxide. Your plant didn't burn. The fungus gnats died. From where you're standing, this looks like a win. But there's a question nobody asks. A question that matters more than whether the gnats died. The fungal network you just damaged underneath the soil. How long does it take to grow back? This is the question that changes everything. Because that network isn't decoration. It's not a bonus feature. It's the main channel your plant uses to pull phosphorus, zinc, and copper out of the soil. It's how your plant survives drought. Because the network holds water, reserves your roots can't reach on their own. Your plant depends on it more than it depends on you watering it. When that network breaks, your plant doesn't die in front of you. That would be easy. You'd know what happened. You'd learn the lesson. Instead, your plant gets quietly weaker. You won't see it next week. You might not see it next month. You'll just notice, somewhere down the line, that things aren't growing the way they used to. And you won't connect it back to the peroxide. Now here's the number that should stop you. In 2025, a research team published a study that tracked soil recovery after the fungal network was destroyed. They didn't run a quick experiment. They watched the same plots of land for 12 years. Their conclusion: it takes nature 12 full years to rebuild a mature root network from scratch. 12 years. To recover from something you can cause in one afternoon, and before you tell yourself, you can just buy fungal spores and reset it. Even with active inoculation, the fastest recovery they recorded was 3 to 5 years. This isn't one outlier study. Another team studied peach orchards, where the soil had been chemically sterilized. After 13 months, fungal colonization had only recovered to 1%. The untreated soil next to it was sitting at 78%. The difference was permanent on any timeline that matters. Here's what this means for you. A seedling you plant today will be a mature, fruiting tree before your soil finishes recovering from the cup of peroxide you poured this afternoon. If you're growing houseplants in pots, maybe this doesn't hit you the same way. When the pot fails, you dump the soil and start over. The cost is small. Real, but small. But if you're growing vegetables outdoors, if you've spent years adding compost, mulching, building structure, watching earthworms appear, watching your tomatoes get sweeter every season, this is what you're putting on the table. The question was never whether peroxide kills fungus gnats. It does. The question is whether a handful of dead gnats is worth 12 years of soil you've been quietly building. I'm not going to answer that for you. That's not my place. But now you know the actual cost. The decision is yours. Part 4. When peroxide is actually the right tool, I want to be clear about something before we go any further. I'm not telling you peroxide is bad. I'm not telling you to throw out the bottle. That would be lazy advice, and it would be wrong. Peroxide is a tool. Like every tool, it's incredible when used for the right job, and a disaster when used for the wrong one. A kitchen knife can prepare your dinner or send you to the emergency room. The knife isn't the problem. The hand using it is. Here's the proof. Peroxide isn't the villain. The commercial organic farming industry uses peroxide-based products every single day. Zero-toll, Purpose, Plus. These aren't drugstore bottles. They're 27 to 33% concentrations with professional-grade stabilizers, approved by the EPA for certified organic agriculture. Farmers use them on crops you eat. If peroxide were as toxic as some people claim, those products wouldn't exist. The problem was never peroxide. The problem is how almost everyone is using it. Let me show you 4 situations where peroxide is genuinely the smartest thing you can reach for. Situation 1. Saving a plant from root rot. Your potted plant is dying. The leaves are wilting, even though the soil is wet. You pull it out of the pot, and the roots are black, mushy, falling apart in your hands. This is an emergency. Without intervention, this plant has days. Take it out completely. Rinse the rot off under the tap. Mix 1 tablespoon of 3% peroxide with 1 liter of water. Pour it gently over the remaining healthy roots. The peroxide kills the Pythium fungus that's eating your plant alive. Repot into fresh soil. You're not destroying garden soil here, because you're replacing all of it anyway. Situation 2. Sanitizing your pruning shears. You just cut a branch off a plant with fungal disease. If you cut the next plant with that same blade, you're spreading the disease yourself. Soak the blades in straight 3% peroxide for 5 minutes. Wipe them dry. The fungal spores are dead. Your metal isn't rusting like it would with chlorine bleach. No residue, no smell, no risk to the next plant you touch. Situation 3. Disinfecting used pots. That old plastic pot you're about to reuse? It's coated with invisible fungal spores from whatever plant lived there before. Spray it with 3% peroxide. Let it air dry. You just saved your next seedling from inheriting the last plant's disease. Situation 4. Pre-soaking stubborn seeds. Some seeds have shells so hard they barely germinate. Morning glory, loofah, nasturtium. Soak them in diluted peroxide. 1 tablespoon of 3% per liter of water. 20 minutes is enough. The peroxide softens the seed coat and activates the enzymes inside. Germination rates jump 30 to 50%. Notice what every one of these 4 uses has in common. Peroxide never touches the living soil of your garden. That's the golden rule. Peroxide is a disinfectant. It belongs on tools, on pots, on seeds. On dying roots, you're removing anyway. It does not belong poured into the soil you've been feeding for years. If you're fighting fungus gnats and you want a solution that doesn't destroy your soil, there are better options. Yellow sticky traps catch the adults. Letting the top inch of soil dry out kills the larvae. A thin layer of coarse sand on the surface stops the next generation from laying eggs. I'll cover all of these in detail in the next video. 5 ways to kill fungus gnats without breaking your soil.